Hello friends, welcome to edupediaword.com. In this video, we'll be deriving the values of some commonly used trigonometric ratios like 0 degree, 30 degree, 60, 45 degree and so on. We'll be deriving sine, cos, tangent, etc. of these values. First of all, it should be clear in mind that something or anything when divided by 0 is a not defined term, or it is an infinite term. So in the future processes, whenever we encounter such a term, we will replace the something over 0 or anything divided by 0 by a not defined term. Now first, the simplest angle is 0 degree. How to calculate the value of any angle at 0 degree? Friends, if say this angle is this angle in the triangle, that is, we are given this angle as 0 degree. So this angle is definitely not 0 degree. But if we move this line closely to this base, that is bringing this line closely to base, we will finally get this particular figure. In this figure, this hypotenuse is very close to the base, or approximately coinciding or touching the base, and thus angle is 0 degree. Friends, if this is the case, what are the values of P, B and H? B was base, H was hypotenuse and P was perpendicular. So in this case, perpendicular is 0, whereas B is nothing but has become equal to H. So sine of 0 degree is perpendicular over H. Now perpendicular is 0 and hence 0 over H will be 0. Now cos 0 degree will be base over hypotenuse, but base has become equal to hypotenuse, so it will be B over B, which is 1. Similarly, tangent of 0 degree will be perpendicular over base, but perpendicular is 0 and base is B or H, so it will again be 0. Cosecant is 1 over sine 0 degree, so it will be reciprocal of P over H, that is 0 over H, or it will be H over 0. Something divided by 0 is not defined, so cosecant 0 degree is a not defined term. Secant 0 degree is reciprocal of cos 0 degree, that is B over B again, which is equal to 1. And cotangent 0 degree is reciprocal of tangent 0 degree, that is B over 0, because reciprocal of 0 by B is B over 0. So it is again something or anything divided by 0, which is not defined. Thus for 0 degree, sine is 0, cos is 1, tangent is 0, cosecant and cotangent are infinite, and secant 0 degree is 1. Let us check what is the value of different terms at 90 degree. Friends, we have to make this angle as 90 degree. That is, this line should be perpendicular to the base. That is a condition like this, where this is perpendicular to the base. But we have also to make a triangle to apply trigonometric ratios. For triangle, these two, the top of the two perpendiculars should be touching. That is, this is only possible when these two lines are close to each other. That is, this line is shifted to here, or we can have this particular case where the triangle ABC has become like this. That is, AC is touching AB. Clearly here, AB, that is perpendicular, equals AC, that is P equals H, and B has become approximately or equal to 0. So for such a case, sine 90 degree will be perpendicular over hypotenuse, that is, since P is H, so P over P, which is nothing but cancels and give result as 1. Now cos 90 degree is base over H, base is 0, so something 0 over something is 0. Tangent 90 degree is perpendicular over base. Here perpendicular is P over H, but base is 0. So something or anything when divided by this particular integer 0 gives the value not defined. Similarly, their reciprocal counterparts, cosecant 90 degree will be 1 over 90 sine 90 degree, that is 1 over 1, which is 1. Secant 90 degree will be H over 0, because we have to take reciprocal of this, cos of 90 degree. So H over 0 is again anything divided by 0, which is not defined. Cotangent 90 degree is reciprocal of tangent 90 degree, that is 0 over P or H. 0 divided by any integer except 0 is 0. So for 90 degree we have sine and cosec as 1, cos 90 degree and cotangent 90 degree as 0, and tangent 90 degree and secant 90 degree as not defined. Let us find out what are the values of angles at 30 degree or 60 degree. Friends, if we have equilateral triangle, say ABC, then the property of this triangle is that all the angles are 60 degree and all the sides are equal. Now let us draw a perpendicular from A on BC, a perpendicular bisector from A on BC as AD. Since it is a perpendicular, so this angle will be 90 degree, and for equilateral triangle this perpendicular bisects BC. So if let AB equals BC equals AC equals 2A be the sides of original equilateral triangle, then since this D is bisecting this BC, so BD will become equal to DC, which will be half of BC, that is half of 2A. So this will become A and A, whereas all the other terms are 2A and 2A. And this angle is also bisected by this perpendicular. So this angle will become 30 degree and this angle will also become 30 degree. That is, angle BAD equals angle CAD equals 30 degree. Now in right triangle ABD, we can see that Pythagoras theorem is clearly applicable because it's a right angle triangle, right angled at D. So 2A square, that is hypotenuse square, equals AD whole square plus BD square. 2A square is 4A square. 2A whole square becomes 4A square, and AD square, BD square is nothing but A square. So AD square has become 4A square minus A square, that is 3A square. Or AD, taking under root, we have under root of 3A. Now if we see this angle, that is 4 angle B, which is nothing but 60 degree, we will see that sine 60 degree is perpendicular over hypotenuse. So in this triangle, perpendicular is AD, which we have find out as under root of 3A. So sine 60 degree is AD over hypotenuse, that is AB. Now AD is under root 3A and AB is 2A. So sine 60 degree is nothing but, because this A gets cancelled by A, and we are left with under root 3 by 2. Similarly, cos 60 degree, if we see this angle B is base over hypotenuse, since base is BD here, which is A, and hypotenuse is 2A, so cos 60 degree is 1 by 2. Tangent 60 degree is perpendicular, that is under root 3A over base, that is A, so it is under root 3. Now their reciprocals are cosec 60 degree as h over p, that is 2 over under root 3. Secant 60 degree is this reciprocal, that is 2 by 1 over 2. Cot 60 degree is reciprocal of this. Under root 3 is under root 3 by 1, so we have 1 by under root 3. So these were the ratios for 60 degree angle. If we rotate this triangle, what we will get? We will get another right angle triangle like this. See, on rotating this 90 degree, we get A at D as the base. So this side is under root 3A, and BD as A, and BA as 2A. So what is the benefit of rotating this angle? The benefit is that this angle has become the point of concern, that is 30 degree, and this angle B was 60 degree. So now we can find out the T ratios for 30 degree also. See, sine 30 degree is perpendicular over hypotenuse. Perpendicular is A and hypotenuse is 2A. So its value is A get cancelled by A and 1 by 2. Cos 30 degree is base over hypotenuse. Now base is under root 3A and hypotenuse is 2A. So its value is under root 3 by 2 because A gets cancelled by A. Tangent 30 degree is perpendicular over base. Perpendicular is A and base is under root 3A. So its value is 1 by under root 3. For their reciprocal counterparts, cosec 30 degree is 1 over sine 30, that is this reciprocal, which is 2 by 1 or 2. Similarly, secant 30 degree is reciprocal of this term, that is 2 by under root 3. And last but not the least, cotangent 30 degree is 1 by under root 3's reciprocal, that is under root 3 by 1 or simply under root 3. Let us calculate one more trigonometric ratio, that is with angle -45 degree. Now if angle is say 45 degree, and it should be a right angle triangle also. So the triangle will be like this. Let this angle be 45 degree. If the angle is centered at B and right angled at C, since this angle is 90 degree, for it to be a right angle, then angle A plus angle B plus angle C is 180 degree, which is the property of a triangle. So angle A is 180 degree minus angle B minus angle C. Now angle B and angle C are 45 degree and 90 degree. So on solving this, you will get 45 degree. That is, angle A is also 45 degree. Friends, in triangles chapter you will study that if these two angles are equal, then this side, that is the side corresponding to them, will be equal. So by that theorem we can say that BC equals AC. Say it be A. So by Pythagoras theorem we can find out AB also. That is, AB square equals BC square plus AC square by Pythagoras theorem. BC square is A square and AC square is again A square. So what we have got, AB square equals A square plus A square, that is 2A square, or AB is under root of 2A square, that is under root 2A. So if we want to calculate the sine, cos, tangent, cosecant, all these terms for 45 degree, we can easily calculate this by the sides found out by us. That is, sine of 45 degree, cos 45 degree and tangent 45 degree can be found out as sine 45 degree is perpendicular over hypotenuse. Perpendicular is A and hypotenuse is under root 2A. So sine 45 degree is A get cancelled by A and we are left with 1 by root 2. Similarly, cos 45 degree is base over hypotenuse. Base here is A and hypotenuse is 2 under root 2A. So again we get 1 by under root 2. Tangent 45 degree is perpendicular over base. Here perpendicular and base are same, that is A over A. So we are left with 1 because A get cancelled by A. Now cosecant 45 degree is reciprocal of sine 45 degree. So it will be under root 2 over 1, that is under root 2. Secant 45 degree will be reciprocal of 1 by root 2, that is the same term, root 2. Cotangent 45 degree will be reciprocal of 1, that is 1 over 1, which is 1. So friends, these were some derivations of some common angles and their trigonometric ratios. Here is a tabular representation of what we have studied so far. That is, sine at 0 degree is 0, 30 degree is 1 by 2 and so on. So by this table you can easily find out the values which we have derived in this whole video. Friends, this table, if once learnt, will help you in solving many trigonometric problems and almost all problems in your course. And this table can be learned by proper practice. So friends, that's all in this video. Thanks for watching Edupedia Word videos.